at least the medical literature recently, and there's a lot written on it in our neurology literature about injuries to the brain and about when you see diffuse axonal injury. And this is just to give some background on it. There's a lady named Stritch who started working on biopsy specimens back in the mid-50s, and she noticed that she was seeing a lot of white matter lesions that she thought were due to stretch of the axons, maybe some small areas of hemorrhage. They seen in the corpus callosum, other white matter tracts. You may see hemorrhage on MRI if it's severe in these areas. Standard MRI does not show that, but it can be identified on some specialized MRI studies. This is just a little slide, actually a little too busy, I think, to show very much, but this presumably shows the white matter tract, so you can see how you would get injuries along here. These are just showing supposed disconnections between the networks of white matter. And you can see these little areas of hemorrhage here. This is the corpus callosum on a coronal view. And then diffuse tensor imaging is the new technique that's being used to look at white matter tracts. Diffuse tensor imaging has been around a long time on a research basis, but it's not, at least in my area, it's not something that I can order on my patients. Now, in some areas, maybe it is, but it's not a common clinical study. These studies are used, I think there's some academic interest in it, and they're really fascinating when you start looking at how sensitive diffusion tensor imaging is for various different disorders. But it's being used to look at brain injury. And the focus is on trying to find an objective measure of mild brain injury. That's the focus, okay? Severe brain injury you see on normal MRI. Mild brain injury, how do you identify that? And we'll talk about that more as we get into the concussion, because you all are familiar with the syndrome. Patients have a mild head injury, and then they have all kinds of symptoms that they want to attribute to it, and finding an objective basis for that is a challenge. And so I think it's a good idea to focus on some objective identifier of that. Anyway, this is showing a flare image and a diffusion tensor imaging, and you can see that there's this area here they're focusing on is an area that you see over here on this other image. Maybe see a little bit here even on the flare. This is just a little bit more detail about it. You can see they often put false color here so you can see the difference in the normal brain. But here they're seeing a little bit of change in the diffusion tensor imaging, and then they're showing the pathways, and you see a little rent in the pathway. So presumably when you get a head injury, if you did diffusion tensor imaging on all of your patients within a certain period of time, you might be able to see some of this. But we'll talk a little bit later on. Probably diffusion tensor imaging is probably not ready to be used in the manner it's being suggested, but as we get into concussion, maybe we'll talk about that a little bit more. Now let's go into the concussion part of the presentation. Let's talk about the mechanism. I have a little video if I can get this to work.
Side of the head, causing damage to the brain where it hits the skull. The brain is injured at the point of direct impact, and because it bounces back into the opposite side of the skull, the opposite side of the brain is injured.
All right, this video has been edited, and I thought I could control the sound, but I can't. Basically, this is showing the coup and contra coup injury. This fellow's in a